Assalamu alaikum and a very good day to everyone. Today I am going to present a lecture on the Hopital rule. It is a very powerful concept in calculus and it is used to evaluate the expressions when we get 0 over 0 or infinity over infinity form. Many students are confused of the concept that when we substitute a value in the expression and we get 0 over 0 or infinity over infinity form, which is known as indeterminate rule, then how can we deal with such situations? So in such situations, a French scientist named Hopital discussed the rule which involves the derivative of the expression. And in this video lecture, we will and in this video lecture we will delve into the concept of the derivatives and limit. So first of all, we can discuss that what is the limit. Limit means that we are evaluating an expression not on the value but really closer to that value. There are two types of limit involving left hand limit and the right hand limit. So in any coordinate axis, if we are evaluating an expression on the number 1, then if we are dealing with the left hand limit, then we choose a value which is very closer to 1 but one step smaller than 1. The value can be 0.999. This value is very closer to 1 and it is approaching 1 but it is not exactly 1. And the other type of limit involves the right hand limit. In right hand limit, we are discussing the value which is very closer to 1 but one step larger than 1. In such cases, we can involve the value such as 1.0001. This value is approaching to 1 but it is not exactly 1. That is the case which we use in the limits. We evaluate a number or any expression on a value which is closer to 1 but closer to any number but it is not exactly that number. So let us discuss what is Hopital rule. Hopital rule is a method for evaluating the limits of determinant form using derivatives. First of all, we should know that which indeterminate forms does Hopital rule deal with. Hopital rule deals with the indeterminate form of 0 over 0 or infinity over infinity form. So these are indeterminate form because we know that if we multiply 0 by any number, then the answer becomes 0. So in that case, if we multiply 0 by 1 over 0, the answer can be 0. And on the other hand, we know that if we divide any number by 0, then the answer becomes infinity. So in 0 over 0 form, we are dividing 0 by 0. It means we are dividing a number by 0, so the answer could be infinity. In that case, we get two answers of one form and we cannot determine what is the actual answer. So these forms are called indeterminate form. Similarly, if we are dealing with infinity over infinity, then we also get two answers such as if we multiply infinity by any number, then the answer becomes infinity. But if we divide infinity by any number, then the answer becomes 0. So in this case, we get two answers of one form and such forms are called indeterminate form, the answers of which we cannot determine. So in such case, if we are dealing with such kinds of equation, then we take the derivatives of numerator and divide it by the derivative of denominator and then put the limit. If by taking the derivative, the answer is still in the indeterminate form, which is 0 over 0 or infinity over infinity, then we again take the derivative and we this procedure till we get an answer which is determinate and which is a number. Okay, so when we use it, it deals with only two determinate form, which is 0 over 0 or infinity over infinity. Other determinate forms are 0 multiply infinity. They are also two answers of such form. If we multiply 0 by a number, then the answer becomes 0. But if we multiply 0 by a number by infinity, then the answer becomes infinity. So there are two answers of one form, and such forms are the indeterminate form. Similarly, by difference and by exponential form, we know that any number raised to the power of 0 becomes 1. But in case of 0, we know that the answer could be 0, the answer could be 1, or the answer could be infinity. So in such case, such forms are called indeterminate form. But L'Hopital rule only works with two indeterminate forms, which are 0 over 0 or infinity over infinity. But all these forms can be converted into 0 over 0 or infinity over infinity form using algebraic manipulation. Such as if we get a number which is multiplying by another number and it is in the form of 0 multiplied by infinity, then we put the first number in the division, such as if the first number is sin x, then in division it will be 1 over sine of x, and the form will be infinity over infinity. So in such case we can apply the L'Hopital rule, but first of all we have to convert the equation into 0 over 0 or infinity over infinity form. So let us understand these concepts using different examples. First of all, we want to evaluate an expression of sin x over x when x approaches to 0. By simple replacing of values, we know that sin 0 becomes 0, and if we divide by 0, then it will be 0 over 0 form. It means that L'Hopital rule can be applied in such case. L'Hopital rule say that if we get 0 over 0 or infinity over infinity forms, then we take the derivative of numerator and divide it by the derivative of denominator and then put the limits. So derivative of sin x is cos of x and derivative of x with respect to x is 1. So if we now put the values, then it will be cos 0, which is 1 over 1, and the answer is a number which is determined. So it is the simplest form of our limit. Now let us understand this concept by using another example in which we are getting infinity over infinity form. We have given the expression of e raised to power x over x square, and we have the limit when x approaches to infinity. If we put if we replace x by infinity, then it will become e raised to power infinity divided by infinity square, which is infinity over infinity. It means that L'Hopital rule can be applied in such form. L'Hopital rule says that we take the derivative of numerator and divide it by the derivative of denominator, and it will be e raised to power x divided by 2x. We are still getting the indeterminate form because e raised to power infinity and 2 multiplied by infinity becomes infinity over infinity. In such case, we will again apply the L'Hopital rule. As I have discussed before, that we keep on applying L'Hopital rule till we get a number which is determined. Okay, so derivative of numerator becomes e raised to power x and derivative of denominator will become 2 with respect to x. If we now put the value of infinity in place of x, then we get infinity over 2 and the answer is infinity. It is important to know that simple infinity is not an indeterminate form. It is a determined form because if we multiply infinity by any number, then the answer will become infinity. In this case, we are multiplying infinity by 1 over 2 and the answer will be infinity. We are getting a single answer of an expression. It means that it is determined form and it is not an indeterminate form. Now we are dealing with the third case in which we are giving the polynomial ratio in the form of px over qx. First of all, if we put the value of 1 in place of x, then the answer will be 0 over 0, which is indeterminate form. And then we are applying the L'Hopital rule, which says derivative of numerator divided by derivative of denominator. If we do so, then the expression will become 3x square over 1, and then we replace the value of 1, then it will also become 3. In such cases, we can also solve these questions by algebraic manipulation such that x square minus 1 can be divided into x minus 1 multiplied by x square plus x plus 1, and in denominator we have x minus 1, so x minus 1 both are cancelled and we only get x square plus x plus 1. In such case, if we put the value of 1, then the answer will again become 3. But L'Hopital rule is also valid for this case, and simple algebraic manipulation is also valid for this case. It depends on the person which are solving this question that which of the method does he involves. Okay. Okay, so let us discuss the fourth type of examples which are logarithmic form. In the logarithmic form, we are dealing with any expression which involves the log, either it is natural log or log with any base number. In such cases, we again take the derivative of numerator and divide it by the derivative of denominator. First of all, we will check that in such case, first of all, we will check that by replacing the value, are we getting 0 over 0, infinity over infinity form? So in such case, we are getting 0 over 0 form. So L'Hopital rule can be applied in such form, which says that derivative of numerator divided by derivative of denominator. Derivative of log of x with respect to x is 1 over x, and derivative of x minus 1 with respect to x is 1. And then we replace the value of 1 by x, and the answer will be 1. It is a simple number which is determined, and it is not an indeterminate form. So it is the simplest answer of our expression. Type involves the multiple applications in which we are getting 1 minus x square over x square as x approaches to 0. First of all, we will check that at it is 0 over 0, infinity over infinity. So in this case, we are getting 0 over 0 form. It means that Hopital rule can be applied in it, which is derivative of numerator divided by derivative of denominator. 1 minus cos x. The derivative of 1 minus cos x is sin x, because cos x is minus sin x, and minus minus becomes positive and it will become sin x, and we divide by x square derivative, which is 2x. By replacing the value, we are again getting 0 over 0 form, which is still indeterminate form. So we keep on applying Hopital rule till we get a number which is determined. So derivative of sin x is cos x, and derivative of 2x is 2. And then if we replace the value, then it will be 1 over 2. It is the simple number which is determined, and it is not an indeterminate form. So it is the simplest answer of our expression. Now, the common mistakes to avoid, which involves do not use it when the form is not indeterminate. Many students consider that infinity is an indeterminate form. It is wrong to say that infinity is an indeterminate form. Infinity is actually an undefined form. It is not an indeterminate form. Indeterminate and undefined are two different terms. Indeterminate means that we are getting two or more answers of one expression, two or more different answers of one expression. But undefined means we can not estimate it what is its actual value. So these are two different terms, but many students consider it as a same term, and they also consider that infinity is an indeterminate form, but it is not indeterminate form, it is an undefined form. Now, and the second mistake to avoid is that we should take the derivative correctly. In such case, we should learn and understand the derivatives of all the trigonometric functions, all exponential functions, all kinds of logarithmic functions, and all kinds of algebraic expressions. Avoid. Now, the third type of mistake to avoid is we should not forget to apply the limits. After taking the derivatives of both numerator and denominator, we should carefully apply the limit. Now, if the algebraic expression is more simply to solve, then we should go for the algebraic expression manipulation, not with the L'Hopital rule. But you can do any question, any of these methods, because both of these methods give the correct answer. So whatever is easier for you, you can adopt it. Now, common key takeaways are L'Hopital rule works only for 0 over 0 and infinity over infinity form. In case of quotient form, we should take the numerator and denominator derivative separately. But if we are dealing with the product form, then we apply the same product rule, which is first expression as such and derivative of second expression plus second expression as such and derivative of first expression. Okay, so third comes, it can be manipulated multiple times if we need. If we take the derivative and the answer is still in 0 or 0 and infinity or infinity form, then we can again continue to apply L'Hopital rule till we get a number which is not indeterminate. Always verify the indeterminate form first. If other indeterminate forms besides 0 over 0 and infinity or over infinity are in our expression, then L'Hopital rule cannot be applied in such cases. It can only be applied in 0 over 0 and infinity over infinity form. Moreover, it is a very powerful tool that simplifies complex limits. Thanks a lot for watching this video. If you like this video, then don't forget to like, share, and subscribe my channel. Moreover, if you have any questions, then you can write it in comment. Jazakallah.